Second requirement, boosting the grid capacity to handle the fluctuations and renewable energy flows, as well as connecting the grid across the region. That means various regions the power supply more but demand is less, so they have to balance. That means to manage the balance with respect to supply and demand. So whatever the smart grid revolutions there, digitization to now grid management. So smart meters, as of now we have seen in India also we are having smart meters. In smart, they enable real-time monitoring of energy consumption, so we can manage. So if suppose if someone is not using some bulb or something, so automated stop will be there. So how to stop that kind of thing is smart management, smart automation system. So by that way, advanced sensors are needed. That means they provide the detailed grid status information for improved control. And last is more important, data analytics, data science. There AI will involve. That means optimize the grid operations and predict the energy demand, forecast the energy demand, predictions of energy demand. That will be required for smart grid revolution. So we are going to powering the futures. So energy storage innovation, that is there in innovation in Germany. So Germany battery storage, large scale batteries they are using to store the excessive and renewable energy, and that is the pumped hydro. So utilizing the water reserves for energy storage they are using, and hydrogen production. I said of morning sessions are said converting excess electricity into hydrogen for later use. In future also we can use that energy in terms of, so hydrogen production is very important. So Germany and Denmark, they are pioneer in terms of renewable energy. Germany, Denmark are the forefront related to global transition to renewable energy. Their experience in implementing this large scale renewable energy system, they have provided valuable insight in other countries also, seeking to reduce their carbon footprint, enhance the energy security. So this presentation explore the strategies, what kind of strategies they utilize, successes and challenges faced by these two countries, and they strive towards the sustainable energy futures. That means they strive towards this sustainable energy. So what is the energy van? That means what is the policy and ambition will be there. So energy, particular definition point of view, energy van, Germany energy transition is a comprehensive policy framework that aim to shifting from fossil fuel to the nuclear power for renewable energy resource. And the policy makers, the primary goal include reducing the greenhouse gas emissions, increasing the energy efficiency and expanding the share of the renewable energy resources, and ambitious targets. So Germany, their aim is to achieve the significant reduction in greenhouse gas emission by 2050. They want to reduce, with the renewable playing a central role in the meeting this target. With respect to renewable energy, only they are able to reach this target only. So that is their ambitious target is there by making the policy goals only. So German people have utilized solar and wind integration strategy. That means Denmark utilize wind. So they have started feed-in tariffs. So guaranteed payment for renewable energy feed into the grid incentive investment. Those who are working related to solar and wind power projects, ensuring stable revenue streams they will give. That is their policy. Second, priority grid access. That means renewable energy sources have given more priority. Those who are using, they will give more priority to them to access the grid and to facilitate their integrations, to minimize their or curtailment during periods of high productions. And finally, third, Renewable Energy Sources Act also they made. So the EEG provide legal framework, because the government has to provide certain framework to promoting these sources and set some target, those who will expand this kind of thing or driving innovations, investment in this particular sector, so they will help. So these are the three strategies are there to integrate the solar and wind. So modernization of grid in Germany, and it became Germany smart grid approach. So they utilize smart meters, they utilize grid expansion, and they utilize energy storage services. So deployment of smart meter, it will make real time monitoring of energy consumptions and what is the productions, whatever the requirement, what your supply will be there, facilitating demand, response and grid optimization. If it is more supply will be required, they are optimizing the grid. Same thing, grid expansion. So investment will be given to grid infrastructure. That is main important part for accommodate increment share of renewable energy, and they ensure that particular reliable transmission from remote generation sites, remote areas. Also energy storage, because of development of energy storage like a batteries, particularly for electric vehicles, batteries are needed. So such batteries, pumped hydro, they will help to balance the supply and demand and address the intermittency of renewable source. So these are the three different modernization factors of the grid will be there in Germany they utilize. So energy weighing results, success and challenges. So whatever the success and what are the challenges are there. So according to factor in renewable share, Germany has achieved significant progress increasing the share of renewable energy, electricity mix exceeding 50% recent year. And grid stability, they want stable grid. So despite of high penetration of renewable sources, Germany grids has maintained the high level of stability, demonstrating the effectiveness of grid modernization effect. They manage and emission reduction. So Germany has made stride reducing the greenhouse reductions, gas emissions, although further efforts are needed to meet this long-term climate targets. They made some long-term climate targets to maintain the emission reductions, to maintain the grid stability and renewable shares. So these are the key takeaways, lessons from Germany and Denmark. So for that we should work as a policy makers, we should make the system modernize, and how the regional collaboration will take place. These are the three different needs are there, these are the three different targets. So with respect to policy makers, supportive policy must be there. They must support to the people who can utilize, including feed-in tariffs or renewable energy targets. It is very crucial for driving investment in renewable energy. Second, grid modernization. So we have to invest, we have to provide the investment in smart grid. So related to smart grid, the grid expansions and energy storage, and particularly it is essential for integrate this technology with high shares of renewable energy. And third aspects, regional collaboration. So we can see that cross-border energy collaboration. So cross-border energy collaboration is also very important. That will enhance the energy security, reduce the cost and facilitate the integration of variable renewable energy resources. So these are the key takeaway lessons are there from Germany and Denmark. So regional collaborations like a Denmark energy exchange from North Pole. So Denmark participate North Pole. It's a power exchange platform that facilitates the cross-border electricity trading among the Nordic and Baltic countries, as well as enhance the security. So regional collaborations enhance the energy security, in particularly diverging the energy sources, providing the access of larger pool during the period of high demand. And the second, interconnected capacity. That means Denmark particularly has invested in the high capacity interconnections with respect to like Norway, Sweden, Germany, and they enable the large scale electricity trade and they manage the grid balance. That is the main important part. That means first they manage North Pole, second enhance the security, and third interconnected capacity. This is the regional collaborations are there related to Denmark energy exchange. Now the case study point of view, integration of micro and smart grids into that. And one more country is there, Bangladesh national energy system. This is the one of the case study related to sustainable energy system. So according to that, integration of micro and smart grids, if you see in the Bangladesh, the need is reliable and diverse energy mixing will be there. That means reduce the emissions, reduce the energy independence, and also decentralize the energy solutions, and particularly grid stability, and grid must be flexible. This is the main need for reliable and diverse energy mixing will be there. Related to this case study, if you will observe, that means what are the microgrids and smart grids are there. What is microgrids? that is localized energy networks are there, that is called microgrids, and they are having enable energy autonomy, particularly local renewable harvesting. But in smart grid, utilize real-time data. Real-time data will come, and also it is completely automated. And the last case, enhance the grid stability. These are the difference will be there with respect to microgrid and smart grid. So what is the potential of microgrid will be there in Bangladesh? We want to reduce the load. Whatever the load sharing concept will be there. So we have to reduce the load as well as reduce the particular load on centralized grid and energy resilience. So whatever the energy resilience will be there related to energy and reliability and renewable energy motivation. So facilitate the integration of renewable energy, and finally rural electrifications are there. So it will support to rural electrification. These are the potential which we have seen in microgrid integration in Bangladesh. So what are the synergetic benefits with respect to microgrid and smart grid integration will be there? That means energy efficiency will improve, reduce the footprint, especially for carbon footprint and carbon emissions. Third, grid reliance, and fourth, renewable boosting. So all these factors improve the grid reliability, and particularly for autonomy, system will be automated, and community engagement. These are the factors are there, that is the synergetic benefits to utilize for micro and smart grid integrations. What are the key takeaways from that countryside? So they have increased the resilience, they have decreased the footprint, and they have utilized the more renewable energy. They adapted for renewable sources. So in implementation from smart grid bolster system, they have reduced the carbon footprint. So in South Africa energy transition, that is the fourth point of view case study. South Africa is grappling with significant energy challenges are there, including widespread lack of grid electricity or reliance on coal. That was the main factor. So government aimed to develop the renewable energy resources and reduce the carbon emissions and meet the future energy demand. So they particular in these examinations will change the potential challenges of integration of renewable energy, especially for South Africa energy mix will be there. So there are dual challenges, but because demand and crisis. So energy demands in South Africa, they are facing the problem of sustainable energy defects, like leaving many without access for grid electricity. So this is the particular reason of shortage of this property affects a rural area and hindering economic development and social progress. The second factor, over reliance on coal, because this country power supply is critically dependent on coal only, coal fired power plants. Almost they are making sustainable to supply the disruptions and environmental pollution. That is the main limitations because of investment in energy sector research. That is the exhibits this issue. And the government response. What is the government response factor? So government strategies involves expanding the renewable energy resources like solar, like wind, while simultaneously they want to explore options like a gas they can imports or nuclear power. So particularly this will diversify many approaches related to the aim is to ensure that reliable and sustainable energy supply, particularly for a future prospect. So this is the dual challenge, demand and crisis. So renewable energy potential and integration, what they adapted related to that abundant resources. That means South Africa is blessed with rich solar and wind resources. They are rich with that. So they are presenting a valuable alternative for power generations. So renewable energy resources, what they utilize, that means they have helped to reduce the country's carbon footprint and ensure the long-term energy security. Another, they made policy framework. So in 2009, National Energy Regulator NERSA, they introduced the particular law, that is tariff REFIT policy, and this policy aim is to encourage the adoption of renewable energy for establishing the price, particular whatever the good price will be required, frameworks are required for various sources, and thereby they can reduce the burden on coal. Particular they were using the coal fired plants, and market they made dynamics. That means whatever the policies they made, they promoted the fixed purchase of prices, and they buyer and seller framework to for their mirror particular market will dynamic. Then particularly they are having the simulate the renewable energy project. So approach was incentivize investment and facilitate the integration of renewable sources into whatever the national grids they are using. So they want to integrate the solar, they want to integrate with wind. So they made the certain policy, and they based on that they provided certain subsidy and certain reduction in price. So there are certain challenges, and path forward will be there. So resources variable, that is the variability. So integration of renewable energies resources into current grid system, that is the main system we want to study here. So integration of renewable energy factors, that is hurdle because of resource variability caused by the atmospheric condition. Like in India we have the weather, different weather, different places. So overcoming this requirement, the innovative storage solution they provided and grid management strategies they changed. Similar way, limited rural transfer, their rural transfer is very limited. So another challenge, that is also limitation ability for transfer the energy, as especially for rural area like in India for village people. So where the renewable sources are located, and urban areas investing the transmission infrastructure is very crucial in effective integration. And third, that is the third challenge, urban photovoltaics. So in urban area, whatever the photovoltaic system we are using, it's a sustainable option for both private and municipal cases. But they encourage the adoption of photovoltaic system. It can reduce the reliance on national, and particularly they promote the energy infrastructure. So this is the main challenges, and path forward will be there. So another country, that is the case study on renewable energy development in Azerbaijan. So Azerbaijan is focused particularly diversifying the energy sources. Aim is to reduce the reliance on fossil fuels. So they started to work on that direction. Country has promoted sustainable energy stations and solutions. They utilize the renewable energy sectors, and it is growing. So renewable energy capacity is 2022. Hydropower 1000, so 1,159.2 megawatt across 30 stations, and includes major plants like Shamkir and Minigature. So wind energy 66.1 across 8 stations, include hybrid plants like Gobi station and Julfa. And solar energy 51.9 across 12 stations, that is located in one place. Bioenergy 37 megawatt from 2 stations. Total include 1 hybrid plant. So this is the capacity of 2020 in that country. So electricity generation 2022, you can see this is the hydropower, this is the wind, solar and biomass. This is the hydropower. Completely maximum is hydropower. So renewable energy contributed 7% of total electricity production. Total electricity production reached 28 billion kilowatt. So this is the particular another country, that is the Maryland, USA, solar power photovoltaic integration. So objective is they studied and they conducted under the US Development of Energy, and they address high solar penetration. So related to that, whatever the key issues, reverse power flow caused by high solar photovoltaic injections. So potential impact, high voltage level in distribution network, increased short circuit scenario, faulty protections coordinations, and improper functioning of control devices. So proposed solution, regulate the reactive power will be produced by solar photovoltaic to mitigate the reverse power flow. Challenge is very difficult to regulate reactive power because of limitation of energy production from solar power, and development of alternative methods needed to address reverse power flow. These are the challenges are there. So according to that, the case study in this is the real world resilience case study in grid management. So in California, in Texas, in a European country. So California grids has successfully integrated port that is the continent's renewable energy goals. So basically, when we'll see the real world case studies, they demonstrated effectiveness of innovative grid management practices from California solar integration to Texas wind energy expansion and Europe cross-border energy trading. These are the examples to highlight the potential to achieve the reliable and sustainable energy future. Through this, we can get the strategic grid management system and technological advancement. So as per this real world resilience, how we can see the grid management utilized, and they have utilized integration of renewable energy into India's power grids. So now we'll see that explore Indians integration. Now integration of Indian renewable energy resources in India power grid, drawing lessons for international case studies and focusing on Indian context. We'll examine that challenges, strategy and future prospect incorporating renewable energy to meet the climate change goals and while ensuring a stable and reliable power supply. So these are the global and Indian context are there. Global shift, renewable sources like solar and wind are crucial for meeting the climate change, reducing the global warming and providing the carbon free energy. So prices have dropped from rupees 2.5 to 3.0 kilowatt per hour, making them competitive coal based thermal energy. And India's ambitions. So the India aim is 175 gigawatt for renewable energy by 2022 and including 100 watt solar and 60 gigawatt wind, and hydroelectricity once a major contributor in India because for around 20% electricity generation will take place by hydropower, and goal is now 450 gigawatt of solar and wind by 2029 to 30. That is the our country goal. And strategies what we have utilized for renewable energy integrations, same forecasting, same flexible sources, same energy storage. In these aspects, accurate forecasting of solar and wind energy is very essential because of the intermittent nature, and renewable energy management centers use advanced technology including AI and precise prediction, as well as hydro and natural gas provide the flexible power source, but their scale is declining. So coal based power stations are being upgraded for flexible load operations through the long term reliability still under evaluation. Third, energy storage. So we want to get efficient energy storage is the very large scale renewable integrations. Pumped hydro storage dominates, but battery and other systems are rapidly developing. So green energy particular corridors which are we have utilized for construction of transmit renewable power. So these are the certain strategies are there for renewable integration case study, the lessons from India like Denmark, like whatever the Hawaii or like South Australia. So Denmark market based approach including storage, transmission grid, international electricity markets, flexible generation system, and their aim is 100% renewable electricity by 2030. For Hawaii, that is the particular shifted from 92% oil to now significant solar power with battery storage, flexible in thermal oil based production, and increase the energy storage were key. And the South Australia, they manage the high wind generation with synchronous machines with output curtailment and interconnection. So distributed energy resources, they meet the sustainable portions of demand. These are the certain international case study lessons for Indian countries are there. India and Gujarat, there are energy renewable energy actions. The national scenario point of view, the detailed modeling suggests renewable energy curtailment may be necessary for some days. Gas based capacity that can be increased full solar and wind generation. Gujarat's approach, so Gujarat aims for 44 gigawatt for solar and wind energy by 2030. The strategy they include demand side response and flexible operations for the coal plants and battery storage for enhance the renewable energy absorptions. Demand side response, so agriculture account 20% consumptions are needed, mainly for during night hours. As I said already, Indian governments are providing electricity to night hours to them because they are giving water to the plants. So if agriculture provided energy during the daytime using the solar can be reduced 3%. So that is the main case will be there. So this is the renewable energy actions in India scenario. So conclusion point the path forwards. These are the key steps. So integrated grid system with accurate forecasting system, flexible coal plant operations and battery storage and demand management. These are the key crucial renewable energy integrations are needed. And for future outlook, energy from renewable electricity generation capacity must reach 50% of total capacity by 2029-30. And we should provide the 20-25% total electricity generations, as well as looking at providing more gas generation will allow integration of 50% renewable energy generation. So coal will remain an important source for power and energy. So this is the concluding part. Into machine learning, so we have to work data driven insight. So machine learning algorithm extract the valuable insight from large data set, enabling more accurate predictions and informed decision making in energy sectors. And this is useful for load balancing and predictions. Similar pattern recognition. So machine learning will identify the complex pattern of renewable energy. So generations and whatever the consumptions of data will be there, leading to improve the forecasting and optimization of energy system, and it will include the pattern recognition. Adaptive learning. So machine learning can adapt and improve the time they expose the new data also. As I said, we can find out the information with new data, making them well suited for managing the dynamic nature of renewable energy. And then we can integrate and varying load also. So real world load is never static. That is the main factor here. So we can get the adaptive learning. So dynamic nature of the renewable energy integration and varying load, we can make a model, they can adapt and improve over that time as they expose new and new data. So this is the real world success story, how machine learning in modern power grids. So Google's DeepMind. Google DeepMind, they are using the machine learning to optimize the cooling system in various data centers, and resulting 14% reduction in energy consumptions are there. And this idea save the millions of dollars and reduce their carbon footprint. Second, smart wires. Smart wires implemented by machine learning, that solution to optimize the power flow through transmission line. What is the power flow will be there. So increasing the grid capacity and reducing the congestion. And this allows the more efficient use of existing infrastructure. Third, STEM. STEM, they are using a machine learning to optimize the energy storage systems. And they enable the business to reduce the peak demand charges and integrate the renewable energy more efficiently. Storage is the key to peak the load leveling. So I'll stop here. We can now take a break. We'll meet after 10 minutes.